As y'all probably know by now, Vercel and I broke up. I still use them for a lot of the things I'm shipping, but they are no longer a channel sponsor. That means I can talk about things they might not have wanted me to talk about in the past. And today, we're talking about a big one. How to not have a crazy Vercel bill. I see a lot of fear around how expensive Vercel is and these terrible bills that float around online. I've had the pleasure of auditing almost all of them, as in I've dove into code bases that cause these huge bills. And I've learned a ton about how to use Vercel right, and more importantly, the ways you can use it wrong. So I did something I have not done before. I built an app to showcase just how bad things can be. I did all of the stuff that I have seen that causes these big Vercel bills, and we're gonna go through and fix them so that you can find them in your own code base and prevent one of these crazy bills. As I mentioned before, Vercel has nothing to do with this video. They did not sponsor it, but we do have a sponsor, so let's hear from them really quick. This seems like the most innocent thing in the world. You put a video in the public directory, you put it in a video tag, and then you go to your website. Now the video's playing. This is great, right? Totally safe, fine, except that Vercel's infra is expensive for bandwidth. I know people look at it and then they compare to things like Hetzner and they're like, wow, Vercel charges so much for bandwidth. The reason is everything you put in this public directory gets thrown on a CDN, and good CDNs are expensive. The reason you'd want things on a CDN is because stuff like a favicon, which is really, really small, is really, really beneficial to have close to your users. Even Cloudflare has acknowledged this when they built R2, because R2, despite being cheaper to host files, is much, much slower than the CDN here. Because of that, putting stuff in this folder is expensive. And if it's something that you can't reasonably respond with in a single chunk of a request, it shouldn't go in here. My general rule is if it's more than 4 kilobytes, do not put it in here. If you want the easiest thing to put it in, we'll have a small self plug, throw in an upload thing. I'm gonna go to my dashboard. We're gonna create a static asset host, create app, files, upload, go to the public folder, grab, drop, upload. Now, all I have to do, copy file URL, go back here, and just swap the source out. That's it. We just potentially saved ourselves from a very, very expensive bill because we don't charge for egress on upload thing. So instead of potentially spending thousands of dollars, go drag and drop it into upload thing and spend $0 instead. You can also throw it on S3 or R2 or other products all over the internet, but this is the one we built for Next Devs, and it makes avoiding these things hilariously easy. On the topic of assets, though, there is one other edge case I see people coming into, and I made a dedicated example for this. This page grabs 1,000 random Pokemon sprites. And there's a lot of them, and they take quite a bit to load. This is doing something right that I think is really, really important. We're using the next image component. And this is awesome, because if we were using our own images like we had put in public, instead of serving the 4 megabyte Theo face, this could compress it all the way down to 3 kilobytes, depending on the use case. But the way that Vercel bills on the image optimizer is really important to note. By default, on a free plan on Vercel, you get 1,000 image optimizations by default. But then they cost $5 per 1,000. You get 5,000 for free on the Pro tier, but that $5 per 1,000 optimizations, that's not cheap. And we made a couple mistakes in this implementation. One is that we are just referencing these files that are already really small. The ones we're grabbing from this GitHub repo, Poke API, these are already small files. They don't really need to be optimized. It's nice to throw them on Vercel CDN, but it's not necessary. The much bigger mistake we made is how we indicate which images we're cool with optimizing. You'll see here that we're allowing any path from GitHub user content. So if other people are hosting random images on GitHub, they could use your optimization endpoint to generate tens of thousands of additional image optimizations. And I want to be clear about what an image optimization is. If you were to re-render these below at a different size, so we were to change this to 200, a lot of platforms will bill you separately for the different optimizations. If we make a version of this image that's 1,000 pixels wide and tall and a version that's 200, you would pay for both. But on Vercel, you're only paying based on the unique URLs. The important thing to make sure you do right here is that you configure the path name to be more restrictive. So the quick fix for this one is pretty simple. you grab more of the URL. So we go here, we say /Pokemon API sprites master ***. Now this app will only optimize images that come from Poke API. So as long as this repo isn't compromised, you're good. This also goes for upload thing, by the way. If you just call utfs.io here, which a lot of people do, you just set it up so any image on upload thing is optimizable through your app. What you want to do is use the /a/ style URLs, because these URLs allow you to specify an ID that's unique to your app. So in the example I gave earlier, if we were to use upload thing to be the original host, the UID is just this part right here. And now we can only optimize the images as long as if they are coming from my app, because this is the path for files that are from my app. And you cannot serve files from other people's apps if you put the app ID in it like this. So if you're using upload thing and you're also using the next image component to optimize the images of upload thing, please make sure you do it this way. And if you want to change the URLs over, the API will start doing these by default soon. But if you're doing this early enough where that hasn't happened, copy file URL, grab this part, put that after here. So if we wanted to put this optimized image on the home page, image, let's import the image component from next. In the source will be https utfs.io/a/. Did it get that correct from my config? It did. Look at that. Good job, cursor. Now that we've done this, I can grab an optimized image from my host, which is upload thing. You don't have to pay for somebody potentially going directly to that URL, because we eat that with upload thing. And users are now getting a much more optimized image sent down to them instead of the giant 10 megabyte thing that you might be hosting with upload thing. And you don't have to worry about users abusing it, because if they don't have the file in your service, they can't generate an optimized image. This covers a comically large amount of the bills and concerns I've seen. So make sure you're doing this. Optimize your images, especially if you're still putting them on Vercel for some reason. And ideally, take every single asset you have that is larger than a few kilobytes and throw it on a real file host, because Vercel's goal is to do things so they're really fast when you put them in the public folder. Because if you put something like an SVG or a favicon, it needs to go really quick, which makes it more expensive. But you can even use Vercel's blob product, which is similar to upload thing, R2, S3, all of those, and immediately wipe these costs out. Ideally, they would introduce something in the build system that flags when you have large files here and the potential risk. I might even make a ESLint plugin that does this in the future. But for now, just make sure you're not embedding large assets in a way that they get hosted on Vercel. Thing one complete. Okay, that's just bandwidth, but serverless is so expensive. You got to make that cheap too. Let's get to it. Let's say you made a blog and you have a data model that includes posts, comments, and of course, users. Both posts and comments reference users, and you can see how one might write a query that gets all of these things at once. But let's say you started with just posts, and you made an endpoint that returns the posts. Then you added comments. So you added a call to your DB to get the comments. And then you added users. So you added a bunch of calls to grab the right user info for all of the things you just did. You might end up with an API that looks a little something like this. Hopefully, y'all can quickly see the problem here. I was surprised when one of those companies with a really big bill could not. The problem here is we do this blocking call, ctx.db.posts.findFirst, to get the post. Then we have the comments, which we get using the post ID. Then we have the author, which we also get using the post ID, well, the post's user ID. Then we get the users and comments by taking all the comments, selecting out the user ID, and selecting things where those match. This is really, really bad. It is hilariously bad, because let's say your database is relatively fast. Each of these only takes 50 milliseconds to complete. Blocking for 50 milliseconds, blocking for another 50, blocking for another 50, blocking for another 50. This is 200 milliseconds minimum of compute. That should probably be a single instance. The dumb quick fix is to take things that could be happening at the same time and do them at the same time. So we can grab comments and author at the same time. A quick way to do this: make the comments promise, don't block for it. Make the author promise, don't block for it. Now these are both going at the same time. And if we need the comments here, which we do, const comments is await comments promise. Now we have them. Now at the very, very least, we took these two queries and allowed them to run at the same time. But we can do much better than this. This is a real quick hack fix. If you don't have dependencies, like if all of these queries don't share data, you could just run all of them at once in a promise.allSettled. But ideally, we would use SQL. So I could write this myself. Instead, we're going to tell Cursor to change this code so a single Prisma query is made that gets all of the data in a single pass using relations. And look at that. Hilariously simpler. db.post a find first, order by down, but we're also telling it to include the user, because that's the author, as well as comments. But in those comments, we also want to include user. So we get all of the data back directly here. Here they're cleaning up because the data model I actually had for this was garbage. But honestly, when we get this back, we have post, which has the user in it, which is the author. I should probably have named that properly. Whatever, too late now. And we have comments, which have users as well as the comment data, all in one query. This means that this request takes 4 times less time to resolve. And I shit you not, one of those massive Vercel bills I saw, requests were taking over 20 seconds. And the average request had over 15 blocking Prisma calls, most of which didn't need data shared with each other. So a single promise.all cut their request times down by like 90%. Then using relations, cut it down another like 5%. And I got the runtime down in an Uber in 30 minutes from over 20 seconds. The requests were often timing out down to like 2 in very, very little time in an Uber without even being able to run the code. You need to know how to use a database. And one of my spicy takes is that Vercel's infrastructure scales so well that writing absolute garbage code like that can function. If you were using a VPS and the average request took 20 seconds to resolve, I don't care how good VPSs are. You wrote something terrible and your bill is still going to suck, or users are going to get a lot more timeouts or requests bouncing because the server is too busy doing all of this stuff. Vercel did just add a feature to make the issue here slightly less bad, which is their serverless servers announcement. Check out my dedicated video on this if you want to understand more about it. The TLDR is when something is waiting on external work, other users can make requests on the same Lambda, so each request isn't costing you money. Because if these DB calls took 20 seconds, then every user going to your app is costing you 20 seconds of compute. With the new concurrency model, at the very least, when you're waiting on data externally, other users can be doing other things, so it reduces the bill there a little bit. And by a little bit, I mean half or more sometimes. So it is a big deal, especially if you have long requests. Like if you're requesting to an external API for doing generation, for example, very good use case for doing something like this. If you're waiting 20 plus seconds for an AI to generate something for your users, paying the 20 seconds of waiting for every single user sucks. And this helps a ton there. There are other things we can do to help with that though. One of those things, I didn't take the time to put it in here, is queuing. Instead of having your server wait for that data to come back, you could throw it in a queue and have the service that's generating your stuff update the queue when it's done. There are lots of cool services for this. Ingest is one of the most popular. Had a really good experience with them. They allow you to create durable functions that will trigger the generation and then die. And then when the generation is done, trigger again to update your database. Really cool in order to avoid those compute moments entirely. Another that I've been talking with more is trigger.dev, open source background jobs with no timeouts. This lets you do one of those steps where you're waiting a really long time for Dolly to generate something without having to pay all of the time to wait for your service sitting there as this thing is being generated. So if you do have requests that have to take long amounts of time, you should probably throw those in a queue of some form instead of just letting your servers eat all of that cost. These solutions all help a ton, be it a queue or the concurrency stuff that Vercel is shipping. At the very least, you should go click the concurrency button because it's one click and might save you 80% of your bill. All of the things I just showed assume that the compute has to be done, but you don't always have to do the compute. Sometimes you can skip it. Let's say theoretically, this query took a really long time. It didn't take 100 milliseconds. Maybe it takes 10 seconds. But also, the data that this resolves doesn't change much. We can call things a little bit differently. If we have const cached post call equals unstable cache, stable version of this coming very soon, as long as Vercel gets their stuff together before NextConf. Here, I need to import DB. Now we have this function, cached post call. I should name this better because post call has a specific meaning. Cached blog post fetcher. Now, with this special cached blog post fetcher function, the first time it's called, it actually does the work. But from that point forward, all of the data is cached. And now you don't have to do the call again. So if this call took 10 seconds, now it's only going to take 10 seconds the first time. This is a huge win because now future requests are significantly cheaper. And if you can find the points in your app where things take a long amount of time and don't change that much, huge win. But they do change sometimes, and it's important to know how to deal with that. So let's say we have a leave comment procedure. It's a procedure where a user creates a comment. So context DB comment create, and we create this new comment. Let's not return just yet, though. We'll await this. Const comment equals that. But now this old cache is going to be out of date, and it's not going to show the comment because this page got fetched earlier. Well, that's pretty easy to fix. All you have to do is down here, revalidate tag, post. And now, since we called revalidate tag with this tag, Vercel is smart enough to know, okay, this cache is invalid now. So the next time somebody needs the data, we're going to have to call the function again. But now you only have to call this query, which we are pretending is very slow, once per comment. So when a user leaves a comment, you run this heavy query. But when a user goes to the page, you don't have to because the results are already in the cache. And we've just changed the model from every request requires this to run to every comment being made requires it to run, but then nobody else has to deal with it from that point forward. Huge change. A common one I see is users who are calling their database to check the user and get user data on every single request. That is a database call that is blocking at the start of every single request you do. If instead you cache that user data, then most of those requests will now be instantaneous instead of being blocking on a DB call. Huge change. So this will not only make your build cheaper, it'll also make the website feel significantly faster. You don't have to wait for a database to be called in order to generate this information. I'm seeing some confusion about unstable cache. I want to call these things out. This cache isn't running on the client at all. The client has no idea about any of this. Things like React query, things like stale while revalidate, all of that stuff, for the most part, is client-side things to worry about. This is the server. The server is making a call to your database to get this data. And you are telling the server when you wrap it with unstable cache, hey, once this has been done, you don't have to call the database anymore. You can just take the result. This is kind of just a wrapper to store this in a KV store in Vercel's data center, or if you implement it yourself, wherever else. You could do this yourself by writing the function a little differently. I'll show you what the DIY version would look like. DIY cache blog post. So first thing we have to do is check our KV. So I'm assuming we have a KV. Const KV result equals, await kv.getPost. I don't actually have a KV in here, so ignore the fact there's going to type error. If KV result, return KV result. Otherwise, we do the compute. We set the result, and then we return it. This is effectively what Vercel's cache is doing. They have some niceties to make it easier to interop with and validate things on. I've DIY'd things like this so often in my life. Vercel gave us some syntax sugar for it, but you can DIY this if you want to yourself. I could rewrite the unstable cache function and just throw it in KV if I wanted to. But this is using a store in the cloud to cache the result of what this function returns. So you don't have to call it again if you already have the result. As you see here, if we have the result, we just return it from the KV. Otherwise, we run the other code again. Think that helped clarify that one. That all said, if you know anything about blog posts, you might be suspicious of this example in the first place, because you shouldn't have to make an API call to load a blog post. You should be able to just open the page and have the blog post. And here's another one of those common failures I see. You might have even noticed it earlier if you're paying close enough attention. See this export const dynamic equals force dynamic call here? This forces the page that I'm on to be generated every time a user goes to it. This page doesn't have any user-specific data. We have this API call, but this one doesn't use any user-specific data. We have this void getLatest.prefetch call, which allows for data to be cached when things load on the client side. We don't even need that, though. We can kill it. Nothing on this page is user-specific. So loading this page shouldn't require any compute at all, but because we set it to be dynamic, it will. And this whole page is going to require compute to run on your server every time someone goes to it. If you have pages that are mostly static, like a terms of service page, a blog, docs, all of those things, it's important to make sure the pages being generated are static. Thankfully, Vercel makes this relatively easy to check. If you run a build, they will just show you all of these details in the output. And they don't just show it when you run the build locally. I can also go to my Vercel deployments and go take a look. So we'll hop into QuickPig, which is a service I just put out. And in here, we can take a look at the deployment summary and see what got deployed in what ways. We have the static assets, the functions, and the ISR functions. And it tells you which does what. The more important thing that's a little easier, in my opinion, to understand is in the build output, it shows you here each route and what it means. So the circle means static. The F means dynamic. And you want to make sure all of your heavy things like your pages that are static because you want the user receiving generated HTML. You don't want to have a server spin up to generate the same HTML for every user when they go to every page. Back to image optimization for a sec, because I know I showed you how to use them right. And as long as you have less than 5,000 images, honestly, you should probably use their stuff. It is very good and very convenient. Despite being pretty happy with the experience of using the next image component on Vercel, once you break 5,000 images, price gets rough. That's why the example loader configurations page is pretty useful here. Frankly, I'm not happy with either the pricing or the DX around any of these other options, but they are significantly cheaper if you want to use them. Sometimes they're more expensive, but for the most part, all the options here are cheaper. They have their own gotchas. I've been to hell and back with Cloudflares to the point where I'm putting out my own thing in the near future. If you need to save your money now, take a look through this list and find the thing that fits your needs the best. But in the future, image.engineering is going to be a thing. I am very excited about this project. I've been working on it in the background for a while. If you look closely enough at the URLs on PickThing, you'll see that all of the URLs on this page are being served by image.engineering already. We're dogfooding it. We're really excited about what it can do. And in the near future, you'll be able to use that too. So for now, if you need to get something cheap ASAP, go through the list here. If this video has been out for long enough, or maybe just check the pinned comment, I'll have something about image engineering if it's ready. But for now, use Vercel until you break 5,000 images. If the bill gets too bad, consider moving to something like anything in this list. And keep an eye out for when our really, really fast and cheap solution is ready to go, which will be effectively a drop-in and have some really cool benefits as well. So yeah, one last thing. There's a tab in everyone's Vercel dashboard for everyone's Vercel deployments that seems very innocent. Analytics. You will notice that you do not have it enabled. There's a reason for that. These analytics events are not product analytics. If you're not familiar with the distinction, product analytics are how you track what a user does on your site. So if you want to see which events a specific user had, that's product analytics. So track the journey of a user. If you want to know which pages people are going to, you want to have a count for how many people go to a specific page, that is web analytics. Web analytics is like the old Google Analytics type stuff. Product analytics is things like Amplitude, Mixpanel, the tools that let you track what users are specifically doing. My preference on how to set this up is to use PostHog, and thankfully, they made a huge change to how they handle anonymous users. They also made a really useful change to their site, Theo mode, which hides all of the crap. It makes it much nicer for videos, so thank you to them for that. But what we care about here is the new pricing, where it is 0.005 cents per event. And that is the most expensive ones. And the first million are free. So you get 1 million free events. The next million are at this price. But if you're doing 1 million events, you're probably doing 2 million events. This is the more fair number. So we're going to take this number. We're going to compare it here. So that is at 100,000 events times this. $3.43 versus $14. Pretty big deal there. Interesting. Apparently, the Web Analytics Plus product has a cap for how many events you can do a month, even in the Pro window. Enterprise can work around it, but 20 million events is a pretty hard cap. Like, we can even get close to that with Upload Thing. So yeah, not my favorite. Certainly not at the $14 per 100,000 event pricing, and certainly not for $50 a month. Generally, I recommend not using the Vercel Analytics, but if they do get cheaper in the future, I'll be sure to let you guys know so you can consider it. One last thing, if you are still concerned about the bill, I understand. The thought about having some massive multi-$1,000 bill out of nowhere is terrifying. They have a solution for that too. Spend management. You can set up a spend limit in your app if you are concerned about the price getting too expensive. You can go in to the spend management tab in billing and specify that you only want to be able to spend up to this much money and even manage when you get notifications. So if you are concerned that usage will get to a point where you have a really high bill, there you go. Bill handled. It does mean your service will go down. So there's a catch there. But the reason this is happening is either you implemented things really wrong or your service went super viral. For what it is worth, I have never enabled this because the amount of compute each request costs for us is hilariously low. So even when we were being DDoSed, the worst bill somebody could generate was like $80 after spamming us for hours straight with millions of computers because they found one file in one of our apps that was like 400 kilobytes. So if you implement things well, you almost certainly won't have problems. My napkin math suggested that for us to have a $100,000 a month bill, we'd have to have 1 billion users. So you're probably fine. But if you are the nervous type, I understand. Go hit the switch. I hope this was helpful. I know a lot of y'all are scared about your Vercel bills, but as long as you follow these basic best practices, you can keep them really low. Our bill has been like $10 a month for a while and not counting seats. It's not a big deal. Highly recommend taking advantage of these things and continue using things like Vercel. All of these tips apply other places too. It's not just Vercel. You can use these same things to be more successful on Netlify, Cloudflare, any other serverless platform. And these things will also speed up your apps for using a VPS. Build your apps in a way that you understand and try your best to keep the complexity down. In the end, the bill comes from the things you shouldn't be doing. Until next time, peace nerds.